Hello, it's Mrs. Trombley. It's time to review how to solve one-step equations. I know that you were already introduced to this last year. It's going to be really super important in algebra this year. So let's review. First of all, what are you trying to do when you solve an equation? Well, the goal of solving any equation is to find the value of the variable that makes the equation true. In order to find the value of the variable, you have to get the variable alone or isolate it, right? Now, I know that for many of these, especially one-steps, you're able to guess and check. But guess and check is not a method that you want to use when you're trying to solve quadratic equations, for example, like you're going to do later, or absolute value equations, like you're going to do later. So we need a step-by-step process that makes sense when you're trying to solve these. So again, when you ask me, can I just guess, or I did it in my head, or do I have to show my work? You do have to show your work. I don't want you to just do these in your head, because these are the kind of, I call them baby bear equations that lead up to the steps to solving the tougher ones that you can't do in your head. So just bear with me, show all your work, show your check, suck it up, buttercup, I don't know what else to say. I need you to have this step-by-step idea and process in your head for the equations that get tougher later. So here are 4 different kinds of one-steps. This is a one-step addition equation because the variable has something being added to it. This is a one-step subtraction because the variable is being subtracted by something. This is one-step multiplication because the variable is being multiplied by something. And this is a one-step division because the variable is being divided by something. Now, there's all different ways. These aren't the same kind of one-step, so we don't just use the same process for each one. It does take one step to solve each one, and that's why they're lumped together in the same category. The addition and subtraction equations kind of end up being the same process because we've learned to change all of our subtraction to addition by adding the opposite, right? So let's take this first one, the one-step addition equation. It's your job to figure out what value of y makes this side equal to this side. So first off, I want you to look at each equation like a little balanced scale. Here's the equal sign. And right now, this side is just as heavy as this side. They're worth the same amount, okay? So in order to isolate this y, you have to ask yourself, what do I need to do to get this -2 to go away, right? And we've talked about combining like terms, so think about your knowledge of that. If you're taking y plus 2, and I just want y to be here alone, how can I cancel out this 2 that's being added? How do you cancel out a positive 2? Well, you learned about additive inverse, right? Isn't 2 plus -2 0? So if I added the opposite of 2, if I added a -2 to this side, what's y plus 2 plus -2? Well, 2 plus -2, those are like terms. They cancel out. They're equal 0. And isn't y left? But now the thing is, you just added a -2 to this side, and these are supposed to be balanced. So if I want them to be balanced again, whatever I did to this side, I need to do to this side as well. So if I added a -2 to this side, I also need to add a -2 to this side so I can keep that equal sign there. Otherwise, this one's not going to weigh the same as that. So now let's combine like terms on this side. A -5 plus a -2, same sign, add the digits, keep the sign. Now y is isolated, and according to this, we got y equals -7. To make sure that we're right, replace the y with -7, add 2 to that, and see if you get -5. Is -7 plus 2 -5? Yeah, so we know that y is -7. And I know you could have guessed that y was -7, but I want you to have that process down that, hey, whatever number is being added to the variable, all I need to do is add the opposite of it, and the variable's isolated. With the one-step subtraction, I'm going to want you to keep change. And draw your line to separate the two so you know that whatever you do to one side, you do to the other. Here's the x that I want to be by itself. Currently, a -3 is being added to that x. If I want to cancel that out, all I need to do is add the opposite of -3. What's the opposite of -3? A positive 3. So if I'm combining like terms on this side, x plus -3 plus positive 3, the -3 and positive 3 are like terms. When you add them, you get 0, and x plus 0 is x. Because you made this side heavier by 3, though, it's not balanced anymore, so you need to make this side heavier by 3. A -4 plus 3 is -1. That's our answer. To make sure that it's right, plug it back in. -1 plus -3 should equal -4. Does it? Yeah, it sure does, so we know that we're right. So when you're trying to solve one-step addition equations and subtraction, you end up changing to addition anyways, right? You're going to do the same thing. You just add the opposite of whatever's being added to the variable to both sides. Because when you add opposites, you get 0, right? And the goal is to try to get y plus 0 and x plus 0 because that gives you y and gives you x and they're isolated. Now the one-step multiplication and division equations are a little different here. I'm going to draw my line down. I have 4 times p equals -28. And a lot of people want to add a -4. If you add, don't write this down, I'm going to write this down. If you took 4p plus -4 and I asked you to simplify this by combining like terms, would this give you p? Would it get the variable by itself? No, those aren't even like terms. You can't do that. They won't combine. So now we've just added an extra number there and we don't have p by itself. In order to get p by itself here, because they're being multiplied, I don't want it to be 0p. I know that adding opposites gives me 0, but I don't want 0p. What I actually want is 1p. Because 1 times p, this sounds ridiculous. I know I should have used a different letter, but I didn't, whatever. So we want 1p, because isn't 1p, that means 1 times p? And 1 times anything is that other number, right? So if our goal here is to get 1p instead of plus 0, how do you get 1? Well, you divide a number by itself, right? So for the one-step multiplication equations, all you need to do is opposite operation here. If you take 4p and you divide it by a +4, and I know that you have to have like terms in order to add, but we're allowed to multiply and divide on like terms. It doesn't have to be the same. So 4p divided by divided by 4. 4 divided by 4 is 1, right? So we'd be left with 1p, and 1 times p is p. Now because you divided this side by 4, you've now changed the value of it. You need to divide this side by 4 as well. You have to do the same thing to both sides. Otherwise you change the value of it, and you make one side heavier or lighter than the other. -28 divided by 4, divide the digits at 7. One of each means it's negative. So right now we're thinking that p is -7. To check to make sure that's right, go back up to your original equation. 4 times -7 should be -28 if we're right. And is it? Yeah. So we know that we're right. So to solve a one-step multiplication equation, all you need to do is divide by the coefficient of the variable. We didn't change any signs here, right? What would have happened if I divided by a -4 instead? Isn't 4 divided by -4 -1? I don't want to get negative p. I want a positive p. I know. Yeah, that sounds so funny. All right, anyway, one-step division. Last kind of one step that we're going to look at, and then we'll just do some examples here. We want to isolate that variable, right? I want this m to be by itself. And I don't want to get 0m because 0m means 0. I'm trying to get 1m right now. So if m is being divided by 6, how can I get m by itself? How can I make this 1m? Well, you learned that when you multiply reciprocals, you get 1. For example, you don't have to write this, but if I took 2/3 and I multiplied it by 3/2, when you multiply reciprocals, you end up getting 1, right? Or 2 times 3 is 6, and 3 times 2 is 6, and 6/6 is 1. So if I want this 6 to go away, that's in the denominator spot, all I really need to do is multiply by a fraction where 6 is in the numerator spot. It really looks like this. So to undo the division, I'm going to use multiplication. Just like to undo multiplication, I use division. These 6's will cross cancel, and I'm left with m divided by 1, which is m. But the thing is, I just multiplied this side by 6. That means I need to multiply this side by 6 also. And a -5 times 6 is -30. So notice, I didn't change any signs. All I did was I multiplied by what the variable was being divided by, because that allows me to cross cancel and get the variable divided by 1. And any number divided by 1 is itself. And whatever you do to one side, you do to the other. So no sign changing in these. So we think right now that m is negative 30. To make sure that we're right, go back up to your original equation. Is negative 30 divided by 6 equal to negative 5? Yeah. When you divide 30 by 6, you get 5, and a negative divided by a positive is a negative. So we know that we're right. All right, let's try a few. Maybe you want to hit pause and try these on your own and then see if you're right. All right, welcome back. Let's see how quickly we can wrap these up. I'll make it like a present and wrap it up. First off, I'm going to draw my line down from the equal sign, and I noticed this is an addition equation. There's a number being added to the variable. So if my goal is to get x by itself, I know to cancel out a number that's being added, I just add the opposite of it. So this is different than multiplication and division. And I already just wrote down what I did on the other side as well, because whatever I do to one side, I have to do to the other. 4 plus negative 4 is 0. X plus 0 is x. Negative 10 plus negative 4 is negative 14. You're done. To make sure that you're right, all you need to do is plug that negative 14 back in for the x. So negative 14 plus 4 should give you negative 10. Is negative 14 plus 4 negative 10? You betcha. So we know that it's right. All right, look at the next one. This time the y comes second. That's okay. My job is still to get this y by itself, wherever it's at. So I want this negative 5 that's being added to go away. To get rid of a number that's being added, you add the opposite of it to both sides. So negative 5 plus 5, those are like terms. They equal 0. So 0 plus y, what's that? It's y. Negative 18 plus 5 is negative 13. So y equals negative 13. To make sure you're right, you would take negative 5 plus negative 13 and ask yourself, does that give me negative 18? Yes, Aruni, positively. It does. We're right. Next, I see some subtraction. I'm going to keep, change it. Only change the sign of the number that follows the subtraction sign. So this is really an addition equation. It's okay that the n is over here. There's not a law that says that it always has to be on the left. So I want it to be by itself, and it's okay for it to be by itself on that side of the equation. I want to get n by itself over here. To get rid of a number that's being added to the variable, I add the opposite of it. I do that to both sides. I'm not adding a positive 13, because if you add 13, then n's not by itself. I need to add the opposite of whatever's on the same side as the n. So negative 3 plus 3 is 0, n plus 0 is n. Negative 13 plus 3 is negative 10. To make sure that you're right, negative 13 is supposed to equal whatever n is plus negative 3. Is negative 10 plus negative 3 negative 13? Yup, so it's right. Alright, next 3. I have negative 3y equals negative 21. I'm hoping that you're recognizing that this isn't an addition equation. This is a multiplication equation. So adding 3 to both sides isn't going to get y by itself. It's just going to give me negative 3y plus 3, because those aren't like terms. So when you have a multiplication equation, you're trying to get 1y. In order to get 1y, I need to divide by whatever y is being multiplied by. Negative 3 divided by negative 3 is 1, and 1y is y. Whatever you do to one side, do to the other. Negative 21 divided by negative 3 is 7. To make sure that you're right, plug it back in. Negative 3 times 7 should give you negative 21. And it does. Yippee skippy, we are right. Look at the next one. Oh my goodness, the n is on the right. That's okay. Your job is to get n by itself no matter where it is. So n can stay put where it's at. But it says, I want to be by myself. Get rid of this 4, please. How do we get rid of a 4 that's being multiplied? We divide by it. 4 divided by 4 is 1, and 1n is n. So we've achieved our goal of getting n by itself. Whatever you do to one side, do to the other. Negative 20 divided by 4 is negative 5. If we're right, then negative 20 should equal 4 times whatever n is. Negative 20 does equal 4 times negative 5. We know that we're right. All right, last one like this. I have negative p equals negative 24, and sometimes people think, well, p is already by itself. It's not. P has a negative sign in front of it. I need that to go away. And this comes back to remembering that when you see negative p, this really means negative 1p equals negative 24. And I think rewriting it is helpful in this situation, so you understand how to get rid of that negative sign. This means negative 1p equals negative 24. So if you want to get rid of a negative 1 that's being multiplied by p, you would just divide by it. Negative 1 divided by negative 1 is 1, and 1p is p. And negative 24 divided by negative 1 is positive 24. All we have to do is throw a 24 in for p, and negative 24 equals negative 24, so we know that we're right. Now for the division, almost there. So in these, the variable's being divided by something. To undo that, all we have to do is multiply by whatever the variable is being divided by. That allows me to get one of the variable. So n's being divided by 3, I'm going to multiply by 3. It technically is 3 over 1, but I'm not going to write that because I don't think you want to either. So those 3's will cross cancel. You're technically left with n over 1, or just the n by itself. Whatever you do to one side, do to the other. Negative 7 times 3 is negative 21. To make sure that you're right, go back to your original equation. When you take negative 21 and replace n with that and divide it by 3, do you get to negative 7? Yep, we're right. Alright, another example, but this time, oh my goodness, I put y on the right. I did that so that you understand it doesn't matter. I can get y by itself on the right-hand side of the equation too. It's okay. Y is being divided by 5. I want y alone. That means I want the 5 to go away, not the negative 12, the 5. To get rid of dividing by 5, I'm just going to multiply by 5. Then I can cross-cancel them to get y by itself. If you multiply this side by 5, you need to multiply this side by 5 as well. Negative 12 times 5, that's negative 60. So we're thinking that negative 60 equals y, or y equals negative 60, same thing. If this is right, then negative 12 should equal whatever y is, which is negative 60 divided by 5. Does negative 60 divided by 5 give you negative 12? Yes. Last but not least, oh, this is another one of those little weird ones where I see the negative in the middle. And we had talked about this before. When you see the negative sign in the middle, it means that either the x is negative or the 3 is negative. It can go with either one, right? I would pick to put it with the 3, because if you put it with the x, then now don't you have another step added? If your goal is to get the x by itself, then don't put something else with the x, put it with the 3. So if you see the negative sign in the middle like this, I would just scribble it out and put it with the denominator so that x can be by itself, or whatever letter there is. So negative sign in the middle means that either the top or the bottom is negative. I would pick the number, not the letter, to make negative. So to get rid of this negative 3, x is being divided by, all I need to do is multiply by it, and I'm going to do that on both sides. That allows me to cross cancel the negative 3's, because this would be in the numerator spot, that would be in the denominator. I'm left with x over 1, which is x. Negative multiplied by another negative is a positive, and 15 times 3 is 45. To make sure that we're right, the original problem said the opposite of x over 3 is supposed to give me negative 15. The opposite of 45 divided by 3. Well, 45 divided by 3 is 15, and the opposite of 15 is negative 15. We're right. You are done. See you tomorrow.